Hello guys, we are Group 3 and we are Team Micro. In this video we are going to discuss and explain our model called Wind Power Plant Model in MATLAB Simulink. So let's get started. Wind power plant is one of the renewable energy sources from wind energy to electrical energy conversion. It is also known as Wind Energy Conversion System or WECSS, and is widely demanding today for making renewable energy sources. In this model we use varieties of blocks. Each of blocks have different purposes and functionalities. In building this model, we start to import the main block, which is the wind turbine induction generator phasor type. In this block, we change the generator parameter value. In nominal power we set it to 1e power of 6, line-to-line voltage of 400, and frequency of 50 Hz. In turbine parameter, we change the value of pitch angle to 0, nominal wind turbine mechanical power of 1e power of 6, and base wind speed of 12 meter per seconds. The rest is the default value of turbine parameter, including the base rotational speed, maximum power of base wind speed, etc., and apply the changes for this block. We can click the display wind turbine power characteristics to see the display and characteristics of wind turbine based on the inputted parameter we set. As you can see in the plot, the wind turbine speed is 1 per unit and the corresponding nominal power output is 1. You can see the base wind speed of 12 meter per second. The dynamic changes occur by decreasing the wind speed to 10.8 meter per second and so on. We set the wind speed by importing step time block. We change the parameter value for the step time in 5 meter per second, initial value of 8 meter per second and final value of 12 meter per second, and apply the changes. For rate limiter, the rising slow slate is 1, falling slow slate of -1, and apply the changes. We also add the import value of 1 for the trip. We add the bus selector to add and combine all signal and wind turbine block. We select the real power, reactive power, rotor speed, electrical torque, and pitch angle and apply changes. The next thing to do is we add scope and add 6 input port to display the 6 signals and apply changes. In 3-phase programmable voltage source, we set the parameter value for the positive sequence, 25e power of 3 for amplitude, 0 for phase degree and frequency of 50 Hz. For load flow, the generator is swing type and apply the changes. We add the 3-phase programmable VI measurement, and check the Use a Label option and apply the changes. Another block is 3-phase transformer. In configuration, the winding 1 connection is set to YG, and winding 2 connection to YN. The type is 3 single-phase transformers and apply the changes. For parameters, the PNVA is 4e power of 6 and frequency of 60 Hz. For winding 1 the voltage is 25e power of 3. (400 volts for winding 2. 500 for magnetization resistance and INF for magnetization inductance, and apply the changes. For 3-phase parallel RLC load, In parameter, the nominal phase-to-phase voltage is 400, nominal frequency of 50 Hz and capacitive reactive power of 400 e power of 3 and apply the changes. We also add another 3-phase VI measurement for wind turbine side. We add power phasor and from block for tagging, and change the go to tag to VABC and update the tag. Same thing for the other tag and apply the changes. We add display block for the each tag to see the output result. Lastly, we add the power GUI and change the simulation type to phasor and frequency of 50 Hz. Before running the model, we set and change the configuration parameter. Start time is 0 and stop time is 10. The solver selection type is variable step and ode 23 TB. The relative tolerance is 1 e power of -4, absolute tolerance of 1 e power of -3 and solver reset method to robust. Now let's run and simulate the model. As you can see from the output power, if we add all this 3 output power signal, we get approximately 9 e power of 5. And as you can see in the scope, the wind power starts to 8 meter per seconds. After 5 seconds, the wind changes to 12 meter per seconds. The real power starts to increase to 1 power after 5 seconds. The reactive power initially high, but after it reaches 12 meter per seconds it starts to decrease to approximately 2.48. In rotor speed, it is little bit greater than 1 per unit because it is acting as inducting generator. Also the pitch angle is maintaining 0 because the power is not greater than 1 per unit. And that is all for our wind power plant model in MATLAB Simulink. Thank you.